Have you ever wondered how your browser communicates with a server? It's a fascinating process, and HTTP response headers play a crucial role in it. These headers are essentially key-value pairs that the server sends to your browser as part of an HTTP response. They're like the server's way of giving your browser some extra information about the response it's sending. For example, you might see headers that tell your browser the date and time when the server generated the response, or the type of content it's sending. These headers can also indicate the size of the response in bytes, or specify how the browser should cache the response. It's a complex system, but it's crucial for the smooth operation of the web as we know it. So if you're ready to dive deeper into this intriguing world of HTTP response headers, stay tuned. Now that we've laid the groundwork, let's delve into some common HTTP response headers. First up is the date header. This handy header indicates the date and time when the server generated the response. It's like a timestamp confirming when your request was handled. Moving along, we find the server header. This tells us about the server software that handled our request. It may specify the server's name, the version it's running, and sometimes even the operating system. It's like a name tag letting us know who's doing the heavy lifting behind the scenes. Next, we encounter the content type header. This one is all about the MIME type of the response body. It could be text or HTML, application or JSON, image or JPEG, or any other MIME type. It's like a label on a package, letting us know what kind of content we're dealing with. Then there's the content length header. This one is pretty straightforward. It indicates the size of the response body in bytes. It's like the weight on a package, letting us know how much data we're about to receive. Lastly for today, we'll look at the cache control header. This one is all about caching directives, which control caching behavior in both the client and intermediary caches. It could specify no cache, max age, public or private directives. It's like a set of instructions, guiding how the response should be stored for future use. These headers give us crucial information about the server and the response, but that's just the tip of the iceberg. We've only scratched the surface of common HTTP response headers. There's a whole lot more to explore and understand. Stay tuned as we continue to navigate the fascinating world of HTTP response headers in our next segment. Continuing where we left off, let's explore some more HTTP response headers. Our first stop is the expires header. This little gem specifies the date and time after which the response should be considered stale, and therefore should not be used from cache. It's a handy way to ensure fresh data for users and avoid serving outdated content. Next up, we have the last modified header. This one is quite self-explanatory. It indicates the date and time when the resource was last modified on the server. It's a useful tool to verify whether the cached version of a resource is still up to date or not. If not, a new version of the resource is fetched. Moving on, let's tackle the location header. This header specifies the URL to which the client should redirect for further action. It's particularly used in the case of 300 series redirection status codes. So if you've ever wondered how your browser knew where to go when a page moved, it's all thanks to the location header. Last but not least, for this segment, we have the set cookie header. This header specifies one or more cookies to be set in the client's browser. It's essential for session management or state persistence. So when you log into a site and it remembers you on your next visit, you have the set cookie header to thank for that. In summary, these headers play a crucial role in managing and controlling the caching behavior and redirections. The expires and last modified headers help manage cache freshness, the location header aids in redirection, and the set cookie header helps with session management and state persistence. They are all small pieces of a larger puzzle that make the web work seamlessly and efficiently. These headers help us manage and control the caching behavior and redirections. But there's more to come. Let's keep the momentum going and look at some other important HTTP response headers. First up is content encoding. This header is used to specify the encoding applied to the response body. Think of it as the server's way of telling the browser, "Hey, I've compressed the data using this method." Common values include zip and deflate. By compressing data, we can reduce the size of the response body, leading to faster data transmission. Next, we have the eTag header. eTag stands for Entity Tag. It's a unique identifier assigned to a specific version of a resource. Why is this useful? Well, it allows browsers to cache resources and make conditional requests. If the eTag hasn't changed since the last request, the browser can use the cached version of the resource, saving bandwidth and improving loading times. Then there's the access control allow origin header. This is a crucial player in cross-origin resource sharing (CORS) scenarios. It tells the browser which domains are allowed to access the resource. By controlling resource access, servers can prevent unauthorized sharing of data and maintain security. Lastly, let's talk about the X-frame options header. This is a security-focused header that tells the browser whether the resource can be displayed in a frame or if-frame on another website. This helps prevent clickjacking attacks, where an attacker tricks a user into clicking a hidden element on a web page. Common values include deny and some origin, either blocking all framing or allowing it only from the same origin. So there you have it. These headers play a vital role in resource access control, content encoding, and preventing security attacks. But remember, this is just the tip of the iceberg. There's a whole world of HTTP headers out there, each with its own purpose and importance. So, keep exploring and learning. But we're not done yet. As we reach the final leg of our journey, let's discuss a couple more HTTP response headers. Firstly, we have the strict transport security header. This header is all about enforcing secure communication. It tells the browser to only access the resource over a secure HTTPS connection for a specified period. This is incredibly important in maintaining the integrity and confidentiality of data between the user's browser and the website. When a server sends the strict transport security header, it's essentially committing to providing a secure connection for a certain duration. It's like a promise of security, if you will. Moving on, let's delve into the content disposition header. This one is particularly interesting as it specifies the presentation style for the response body. The content disposition header is especially useful when we're dealing with file downloads. It allows the server to instruct the browser whether to display the content inline within the browser or to prompt the user to save it as a downloadable file. For instance, if you've ever clicked on a link and it opened a PDF right within your browser, that's the content disposition header at work. Similarly, if you've clicked a link and it prompted you to download a file, that's also the content disposition header doing its job. It's a small but significant part of providing a smooth user experience. To recap, the strict transport security header helps to enforce secure communication by instructing the browser to only access the resource over a secure HTTPS connection. On the other hand, the content disposition header controls how the response body is presented to the user, whether inline in the browser or as a downloadable file. These headers, like all the others we've discussed, play crucial roles in shaping the web experience. They help to secure our data, manage how resources are cached, control access to resources, and so much more. With these headers, we can enforce secure communication and control the presentation style of the response body. So there you have it, a whirlwind tour of HTTP response headers. We've traversed the terrain of these key value pairs that servers send to clients as part of an HTTP response. We've learned about their roles in providing additional information about the response, from the server's capabilities to its preferences and metadata. We've delved into some common examples like the date, server, content type, and cache control headers, and explored their functions. We've also touched on the importance of headers like setCookie, eTag, and strict transport security, among others. These headers vary depending on several factors, such as server configuration, the nature of the request, and the specific requirements of the application or API being accessed. Remember, understanding HTTP response headers is crucial for building robust and secure web applications. So keep exploring and happy coding!